The fastest Lego train was built by Daniel Stoeffler and reached a top speed of 27 kilometers per hour. But what is the fastest a Lego can go, and how would you know how fast it was going? I built a Lego slingshot that was able to send a Lego projectile about 100 miles an hour. Wow, that was fast. Let's see that again. You might be wondering how I know that was 100 miles per hour. I'm going to show you exactly how I figured it out. First, we need to start at the beginning. What is speed? Well, speed is a measure of how long it takes an object to move a certain distance. Many people are familiar with terms like miles per hour or kilometers per hour. That just means the amount of miles or kilometers you would move in an hour of going that speed. We can calculate the speed of everyday things, like the speed of my brother Jared running across this field. We've set up some cones 20 feet apart. I'm going to use my stopwatch to time how long it takes him to run across the cones. So that took him about 1.5 seconds to run 20 feet. Now we need a way to turn that into a unit of speed. The way we do that is by using the speed equation. The speed equation is a mathematical statement of how time, distance, and speed are related. The equation looks like this: r equals d divided by t. If you want to find the speed of something, take the distance it went and divide it by the time it took. For our example, the distance was 20 feet, and it took Jared 1.5 seconds. If we replace d and t with the numbers from out in the field and do the division, we get 13 feet per second. So how did I calculate the speed of the Lego projectile when it was going too fast to observe? Well, to do this, we have to find a way to slow down time. The way we do this is with slow motion video. This is me, and this is Dr. Jim Bales, Assistant Director of the Edgerton Center at MIT. He runs the same high-speed photography lab where Harold "Doc" Edgerton did his pioneering research using strobe lights. On our visit, he set up a special high-speed camera, recording at a wicked fast frame rate. One of the things I love about slow motion is that it allows you to see things that you wouldn't normally be able to see. For instance, in this video of the Lego hitting an empty soda can, you can see some of the leftover soda spray out of the top of the can. We can now calculate the speed the same way we did with my brother in the yard, except instead of seconds, our time is in frames of video. Now, all we need is to know how far the projectile goes in a certain number of frames. So, how do we measure the distance in the video? Well, if you put something like a black and white striped piece of paper along the same plane as the projectile, you can see how many stripes it passes in one frame of video. Then you can use a ruler to measure the stripes so you know how far it went in one frame. Now you can convert your inches per frame into something more standard, like miles per hour or kilometers per hour. Let's do that really quickly. And that comes out to be just about 102 miles per hour. I really encourage you to try this yourself. Most phone cameras now have slow motion on them, and if your subject is slower, you don't even need to use the slow-mo. Once you go out and measure speed, it really gives you a better understanding of how it works. Thank you so much for watching, I hope you all enjoyed, and see you next time.